Hey, hi, I'm Ramya, embedded software engineer at Microsoft Technologies. Today we're going to see how to interface a Raspberry Pi board with AppCOE. So let's see the contents what we are going through today. Okay, before going to see all this, make sure you install the AppCOE on your system. So if you don't know how to install AppCOE on your PC, just click the link I shared here to install the AppCOE on your Windows machine. Just watch the AppCOE installation video so that you get to know how to install AppCOE on your Windows machine. Okay, for interfacing the Raspberry board to AppCOE, so these are the things we required. First, we need to create a optimized AppCOE project. So, how to do optimized AppCOE project, we will see. So, the first one is creating the optimized AppCOE project and importing to the Raspberry workspace. So, what are all the things we're going to do? Let's see. The first one is what are the steps we require to create your own optimized AppCo project? How to set those optimized target code generation for the target Linux? Okay, come let's see that. This is the default workspace of the AppCo when you initially opened it. Now go to help and click installation details. So here you can see the installation details of your AppCo and its a version, everything. So now there is no other installation we done here. Okay, now you select any of demo and go to tools and click optimize target code generator. So now the pop-up window came. You should browse the destination path. So select the path you want to do a code generation. So here I am going to create a new folder named code generation and then click OK. So now we set a destination path and we have to set target. So select target as Linux and the version to be 2.4 or greater, and then the architecture to be 32-bit. Raspbian OS is 32-bit, so that's why we are doing code generation for 32-bit. And then we should select spin lock because it prevents code from overlapping, and select target hardware to be x86 Raspberry Pi, and we should select AppCo project because we are doing here AppCo project. If you want to do makefile, you can select it too. So these are the configuration settings. Make sure all to be correct. Now click next and then it goes to the next window. So there is nothing to change here. You just go and next, and then make sure you select that generate optimized API interface file, and then click next. And then here also there is nothing to change here. Just see all the settings to be as default, and then you can go to finish. So now the target project is generating. Once finished, it will generate a reporting report which displays activities in target code generation, and click done. So now you can exit the AppCo. So these are the main tool chain and plugins we require to use the Raspberry with AppCo. So the first one is ARM toolchain. So let's see how to install the ARM toolchain first. Okay, now we're going to install the required Raspberry software. So for that you go to ARM toolchain and right click Raspberry executable as run as admin. Okay, once the installation window came up, just browse your path. We have installed the standard AppCo once again with the folder named Microsoft Raspberry. Has to install all the plugins in this Microsoft Raspberry folder path. After select the path, just check the accept license agreement box and then click install. So now the installation of your GNU toolchain for Raspberry is going on. So this will take some minutes to complete. Okay, installation is completed now. The pop-up window came, just click OK and then go to SYGCC and bin. So here you can go through the things that we installed the toolchain successfully. Okay, now we install the ARM toolchain successfully. So next we're going to install the GNU ARM C++ development tools. So this is also one of the important tools we have to install. Okay, now we're going to install another plugin toolchains. So go to install new software. Click the add button and give name as a GNU ARM plugin. So this is the plugin we're going to install now. Browse your folder and go to utility Raspberry utility software and go to ARM development tools. So copy this path and then put it on the installation page. So paste it here on the location, or else directly browse the zip file of your plugin folder. Click OK. So now the tools came up, just select the boxes. So cross compiler support and development support, these are the development tools we're going to install now. So check the box and click next. Okay, now click next and then accept the terms of license agreement and click finish. Click OK for this security warning, and then the installing software is going on. Okay, yeah, completed. Click yes to restart your AppCOE. Okay, now installation of GNU ARM development tools also done successfully. Okay, now coming to install remote debugging capabilities. So this listed four plugins are really needed because this remote debugging capabilities plugins listing lot more software. So we require only these four things. Make sure you select these four while installing the remote debugging capabilities. So one is GDB hardware debugger, and then a remote launcher, and then remote system explorer for the end user runtime, and remote system explorer for the user action. So make sure you install all these tools and plugins correctly to use your Raspberry with AppCo. I opened Microsoft Raspberry Workspace. So here I'm going to install new software from the help menu. This is where I'm going to install all the plugins. So once the window came, click add and copy the name and location from the document we provided to you. So paste the name here, that is Eclipse Mass Project, and then copy the link and then paste the link in this location and then click OK. Just wait a second, it is going to fetch and giving you the tools that we're going to install, so you can expand and see the things and select GDB hardware debugging and C++ remote launch and remote system explorer end user runtime, and then user action. These are the four check boxes we have to select for our Raspberry debugging toolchain. So that is also we have given in your document, you can go through it. So click next. Okay, I've clicked next again and then select accept the license agreement and finish. So now the software is started installing.
Just wait for a second, it will take some time. Okay, the installation is done now. Click yes to restart your AppCo.
Okay, the installing plugins are done successfully. And then we're going to import that project into our Raspberry workspace. And then we have to configure the preprocessor settings. So
Okay, now I'm going to open AppCo under Microsoft Raspberry AppCo. So this AppCo is separate for Raspberry things. So you just go this folder which is given by Microsoft as per license. So you just check the AppCo folder, and this SYGCC is the utility software tool for debugging purpose. So above the AppCo you can click that one, and then you can go to the exe file of AppCo, right click, open with system admin. You just open like that manner always. You should browse your path and then select the code generation as you done before, and then click OK. Okay, now AppCo is coming up. So we got a workspace that we selected for a code generation. So click help and go to installation details. Here you can see other softwares we installed. So previously we see only AppCo installation. Now we see other debugging software and remote launch and cross compilation support, remote system explorer, everything for Raspberry things we have installed now. So be sure all this softwares you install properly, and then click close. Now right click to import the code generation project. So select existing project into workspace and click next, and you should select the directory where you created code generation, and then you got the project, then select it and click finish. So now the project came up in the workspace. Right click and go to properties, expand C++ build option, and then click toolchain editor. This is the toolchain you need to select. Using the drop down menu, select cross ARM GCC and ARM Linux GNU Make Builder as a toolchain configuration. Click apply. Now click settings, select the ARM family, and then ARM architecture, and click apply. Remember, just those are all default settings. You no need to change anything. Just you can make sure what are all the options are made in optimization warnings and all. Okay, so next you click cross on GNU assembler. Here you have to change the command. So only the change you have to give the command. So this is the command you have to give, and then click apply. Same command you just copied, and then you should give on cross arm C compiler also. So remove the old one and then give the paste this command, then click apply. Now click arm C linker, and then here also you just paste the same command and click apply. Okay, now we should include the preprocessor symbol from ClassHome GNU assembler. So the preprocessor symbol should be OS target equal to OS Linux. Make sure there is no space between the characters. This is not an actual AppCOE project, it is an imported project on AppCOE. So we should select OS host is equal to OS false. Then Raspbian OS is 32-bit, so we are setting OS CPU 64-bit is equal to OS false. And then click OK. Now click apply and copy the symbols and paste it on cross arm GCC compiler and then click apply. Now click directories. So here you should add the include paths. Go to workspace and expand demo FreeRTAS and add include. Similarly, go to workspace and select optimized interface include and then click OK. So these are the two includes we needed. So copy those two includes and paste it on cross arm C compiler directories. So click apply after paste the include path. Now click environment from right side C++ build. Here you can go to path and then here we should add the path of the tool chain. We have to check from the folder where we install the sysgcc toolchain. So this is the path we need to add. So copy this path from your folder and then go to AppCOE and paste the folder path here. So now we add the toolchain path also and then click apply and OK.
And then we're going to build the demo projects on AppCo. That is, we made already created this optimized AppCo project, right? So that project we will do import and do build. We have a Raspberry demos with the binaries. So we're going to build the demo now.
Expand the demo FreeRTAS and right click, go to clean project. So before going to build your project, make sure you clean the project to remove the unwanted resource and then right click demo FreeRTAS. Right click demo FreeRTAS and click build project. So now building project started. So this is doing a cross compilation. So you can see in the console page the cross compilation building is going on. Okay, fine. Now you can see the cross compilation building is completed successfully, and also you can see the binaries got generated under the demo FreeRTAS. So this is how we doing cross compilation successfully.
We are going to configure the AppCo for remote connection to the Raspberry board. After building the project, we're going to run and debug those demo projects on the Raspberry Pi board and see the console output. So let's see one by one. Okay, we're going to configure SSH server on Raspberry Pi. So how to do that? First, we have to set the host name of the Raspberry Pi in the host machine. Link the Raspberry Pi from the host machine via the command prompt. So let's see that one.
First, you disable the firewall, antivirus, and Wi-Fi on your Windows machine. Then, through a coaxial Ethernet cable or UTP Ethernet cable, connect your Windows machine to the Raspberry Pi board. Make sure that your Raspberry Pi board has been connected with the power cable for Raspbian Linux OS to boot up. The static IP of the Raspberry Pi board is given here in the command prompt. So it has been set from our end. Similarly, you need to set a static IP of your Windows machine IP address. Once you connect the LAN cable to your Windows port, now your Windows has no Wi-Fi, it has only one static IP. Then you open the command prompt and try to ping to your Raspberry Pi board to check the connection. So this is how you ping the Raspberry Pi board, and then you will get the status also once you pick the Raspberry board.
Okay, now we're going to check the Ethernet connection by used putty tool for the Raspberry login credential from the putty tool.
Okay, now you open the putty tool from your machine, and here in putty I am giving the IP address of the Raspberry Pi board to check the SSH connection. So give the same IP address and then click open. So now the command window showing the login as, so you should write as pi, and then password it will ask, so you should write a Raspberry. So then you can get the below things. So make sure you log in as a pi, and then password should be Raspberry. So now we successfully logged on the Raspberry Pi board.
Okay, all this done for configuring the SSH server on Raspberry Pi. So next, coming to next, configuring AppCo for remote connection to Raspberry. So here we're going to connecting the using Remote System Explorer. So after installing plugins, we got this Remote System Explorer icon. So using that, we're going to connect from the AppCo.
Okay, let's coming to the AppCOE. Click the open perspective option. Before that, let's see the help installation details. So here you can check whether you install the tools, everything came correctly. So make sure you installed all the required tool chains. Then you come to opens perspective option and click remote system explorer. So this option, when you install the tool chains correctly, so that it will come, otherwise it won't. So now after you click the remote system explorer, this window is coming up. Then you click new connection. Now the pop-up window came, click Linux and then next. We are going to make a connection between the board and host, so that's why we are making this remote connection. So now you give the host name. So remember this IP address, which is a host name, and then the connection name should be Raspberry, and click next, and then select the ssh.files box, and down also you should select SSH settings and click next. Here you select the process shell Linux and shell process, then click next, and again SSH shell and click next, and select SSH settings and click finish. So you should select all the window as SSH settings. Okay, so now you can see the Raspberry. So now the Raspberry got created. Inside that, click SSH terminal and click connect. So now you can give your user ID should be Pi, and then password should be Raspberry as given in the manual, and then click OK. Now you can see the status is showing connected at the bottom, and now click SSH terminal and launch terminal.
Next, we're going to run the demo projects on Raspberry Pi. So first we need to set the run configuration. After setting up run configuration, just create a new launch configuration and then you run the demo.
So click the project window now and expand the binary. Right click demo free atas and then select run as option and click run configuration. Okay, now the pop-up window will come up and you click the C++ remote application, right click and then you click new. Here we going to run the demo FreeRTOS on Raspberry Pi or Raspbian OS terminal, but we can see the console on the AppCOE itself. So actually the binary is running on the target board. So write this path and command to execute. Now click apply and then now go to the common window and select run and then click apply and give run. Okay, now the demo RTOS has started running. You can see the console output here in the console page, so showing you the execution output, that task, giving the execution control to the task 1 via semaphore 1. So you can read the console output here. So we run the project successfully.
Next, we're going to debugging the demo projects on Raspberry Pi. So set up the debug configuration in AppCOE and then you launch the remote debugger. Then make the default settings for GDB server settings tab. Once everything done, we can easily debug the demo projects, which is useful to find your issue.
So again expand the binary and right click demo free atas and go to debug as option and then click debug configuration. Okay, the debug window came. Make sure demo free atas is selected and then now click select other in below and click standard remote create process launcher and give OK. Now go to debugger and browse the debugger GDB debugger path. So select this particular ARM Linux GDB and click open. So we browse the path for the GDB debugger. Also select the path for the GDB init. So now GDB command line path also we browsed it. Now go to common and select the debug option and click apply and then debug. Before that it will ask you to open different perspective, give yes for that and then the debug window will come up. So here you can see the main function. The debug starts at the point main. So above you can see the option that step over and step into. So using this option you can step over each line of your program and then you want to step into the particular API, you can use step into and then go and check to debug your issue. And then the red color button is used to stop the debug. So this is how you can use a breakpoint at anywhere to debug a particular line of your code and then you can start your debug by using the step over and step in options and then you can stop your debug by using this red icon. So this debugger is very useful to spot your issue. So now I close the debug now. So this is how you debug your application running on your target board. So thank you. I hope you understand how to make the Raspberry connection with your AppCOE. So keep following more artist related videos. Bye.